Hello, we are discussing about GATE 2007 ECE paper, and this question is related to digital circuits. Look at the circuit diagram. The circuit diagram is a standard TTL NOT gate. When Vi is equal to 2.5 volts, the modes of operation of the transistors will be. What is the modes of operation of the transistors? Q1, Q2, Q3, Q4. Whether they will be in active mode or reverse active mode or saturation or cutoff. That you have to specify. So what are the modes of those four transistors? Whenever Vi is equal to V input is 2.5 volts. What you are applying is V input is nothing but 2.5 volts. So whenever it is 2.5 volts. Now standard TTL implies nothing but, remember that one, in standard TTL, okay, a transistor is in on or off. That implies nothing but we are going with digital. That is nothing but either a transistor may be in on condition or it may be in the off condition. So on implies nothing but it will be going into saturation region. Okay, off implies nothing but it will be in cutoff. Remember that one. That is standard TTL. Whenever we are going with low power Schottky TTL, by that time on implies nothing but active region, off implies nothing but cutoff region. So standard TTL is going to be treated as saturated logic family, whereas Schottky TTL is going to be called as non-saturated logic family. The meaning of saturation, non-saturation is nothing but whenever the transistor goes into on condition, if it is going into saturation region, by that time it is saturated logic family. If it is not going into saturation, it is going only into active region. By that time that is called as non-saturation logic family. But standard TTL is going to be called as saturated logic family. By that time transistor in on condition is nothing but transistor will be in saturation. Transistor in off condition is nothing but it will be in cutoff condition. Now, so that now we are going to check this one, Q1. So whenever Vi is equal to 2.5 volts, what happens for this Q1 transistor? Vi is equal to 2.5 volts. The meaning is nothing but whether you are applying logic 1 or logic 0 for this Q1. Okay. So if you are going to checking about the logic levels of TTL at that time, logic levels of TTL is going to be 0.8 volts is going to be the maximum low level. Okay, that is nothing but logic 0, and maximum the minimum high is nothing but 2 volts, from 2 to 5 volts. This is what 2 to 5 volts is nothing but logic 1. So logic 1 level is nothing but it's a range of voltages from 2 volts to 5 volts. Logic 0 implies nothing but it is from 0 volts to 0.8 volts is nothing but logic 0. Okay, logic 0 is nothing but 0 volts to, this is low level, and this 2 to 5 volts is nothing but high level. So Vi is equal to 2.5, so that 2.5 is greater than 2 volts. So what you are applying is nothing but Vi is equal to logic high. Logic high you are applying. Whenever you are applying logic high, that implies nothing but it is NPN transistor. This is NPN transistor, NP and N transistor. So N side you are applying logic high. N side you are applying logic high is nothing but maximum voltage you are applying for N side, and for P side you are applying through a resistor of 4 kilo ohms you are applying 5 volts. So the voltage across this one is going to be lesser than 2 volts. Remember that one. Okay, if the other parameters are given at that time, the voltage across this P side is going to be less than 2 volts. Okay, and here you are applying N side, you are applying more than 2 volts, that is 2.5 volts. That implies nothing but this is called as emitter base junction, because arrow implies nothing but arrow is emitter and this side is base and this side is collector. So that emitter base junction, for emitter base junction, N side you are applying more positive voltage, P side you are applying less positive voltage. So JE will be under reverse bias, so that now no current flows through this one, but definitely current flows because through this 4 kilo ohms, where this current has to go. The current flowing through 4 kilo ohms cannot go through this emitter base junction because you are applying logic high over here. So by that time the current has to move, the current has to move only in this direction. That is nothing but it has to move in this direction, because it is reverse bias, the current flowing through this one is going to be 0. Okay, entire I, whatever we are saying, that I has to go through this collector base junction. This junction is going to be called as JC, collector base junction. Since the current is flowing through collector base junction, this will be called as it is forward bias junction. Since a current is flowing through collector base junction for this Q1 transistor, okay, for this Q1 transistor emitter base junction is reverse bias and collector base junction is forward bias. By that time, this is going to be called as reverse active region. Reverse active region. Active region implies nothing but both the junctions are active region is nothing but emitter base junction is forward bias, collector base junction is reverse bias. But here what we are getting is nothing but emitter base junction is reverse bias, collector base junction is forward bias. So it is reverse condition for the active region. So it is called as reverse active or inverse active region. So Q1 will be in inverse active region or reverse active region. By that time, current is flowing through the base of Q2, that is going to be greater than IB minimum required to keep Q2 in saturation. So Q2 will be in the on condition. That makes Q2 into on condition, and the base drive required for Q2 to be in saturation is IB minimum, and the current supplied is greater than IB minimum. Okay, so Q2 will be on, and whenever Q2 will be on, a large current flows. That makes voltage drop across this one, that is voltage drop across 1 kilo ohm is going to be greater than 0.7 volts. So that makes Q3 is going to be coming into on condition. Okay, because of collector base junction forward bias, a large current flows. That makes Q2 on. Whenever Q2 on, a large current flows through this 1 kilo ohm, and a small current goes through this base of Q3. But this large current is going to be making large voltage drop across this 1 kilo ohm. So that voltage drop is going to be greater than 0.7 volts. That is VBE active, VBE saturation. By that time, this Q3 comes into on condition, and since it is on, at that time the current coming from this 1.4 kilo ohms entirely goes in this direction, and no current is flowing through this one. Q4 will be in off condition. So Q4 will be in off condition is nothing but Q4 will be in cutoff, and Q3 will be in saturation, and Q2 will be in saturation. So Q1 reverse active, Q2 Q3 are in saturation region, and Q4 will be in cutoff condition. So these are the different region of operation, that is modes of operation. Q1 reverse active. Okay, Q1 reverse active, that is the right answer is going to be B. Q1 reverse active, Q2 saturation, Q3 saturation, Q4 cutoff. The right answer for this question is nothing but B. Thank you.